Space exploration has long been a source of fascination and wonder for humanity, a frontier where science meets the unknown. While 12 men have walked on the Moon, our understanding of its surface remains limited. In 1972, the Apollo 17 mission marked the last time humans set foot on the lunar surface. But robotic missions have since carried the torch, exploring areas where no human has ever gone. Among these, China's Chang'e 4 mission stands out as a groundbreaking endeavor. Not only did it achieve humanity's first soft landing on the Moon's far side, but it also unearthed a mysterious, gel-like substance that baffled scientists and reignited global curiosity about the Moon's secrets. Named after the Moon goddess from Chinese mythology, the Chang'e program reflects China's ambitious lunar exploration roadmap. The program comprises 4 phases: orbiting the Moon, landing and roving its surface, returning lunar samples to Earth, and establishing a robotic research station near the lunar South Pole. The Chang'e 4 mission, originally conceived as a backup for its predecessor, Chang'e 3, became a cornerstone of this effort after being repurposed with new scientific objectives. The Moon, Earth's closest celestial neighbor, has been orbiting our planet for over 4.5 billion years. During this time, the gravitational interaction between the two bodies has locked the Moon's rotation with its orbit, causing one side to perpetually face Earth. This tidally locked orientation means that the far side of the Moon, often called the dark side, not because of a lack of sunlight but because of its inaccessibility, remains hidden from view. While satellites and orbital images have provided glimpses of this mysterious hemisphere, no spacecraft had landed there until Chang'e 4. The mission began its journey to the Moon on December 7, 2018, launching aboard a Long March 3 billion rocket. After a 5-day journey, the spacecraft entered lunar orbit on December 12, 2018. Its primary objective was to explore the South Pole-Aitken Basin, one of the largest and oldest impact craters in the solar system. This basin, spanning nearly a quarter of the Moon's surface, is a treasure trove of geological history. Scientists hoped that studying this region would shed light on the Moon's formation and evolution, as well as the early history of the solar system. On January 3, 2019, Chang'e 4 achieved a historic milestone, becoming the first spacecraft to softly land on the Moon's far side. It touched down in the von Karman crater within the South Pole-Aitken Basin. This achievement was made possible by a relay satellite, Queqiao, positioned in a stable orbit beyond the Moon to facilitate communication between the lander and Earth. The relay satellite solved a significant challenge. The Moon's far side blocks direct radio communication with Earth. Once on the surface, the U-2 rover, meaning Jade Rabbit 2, was deployed. The rover's mission was to traverse the lunar terrain, capture high-resolution images, and analyze the composition and age of rocks and soil in the region. This was no small task, as the far side of the Moon presents unique challenges. Unlike the basaltic plains that dominate the near side, the far side is covered in rugged highlands, creating a more treacherous landscape for exploration. U-2 quickly began its work, snapping photos and collecting data as it roamed the surface. However, the mission took an unexpected turn on July 28, 2019, when scientists monitoring the rover noticed something unusual in one of its panoramic images. Inside a small impact crater, a shiny, gel-like substance stood out against the surrounding gray lunar regolith. This peculiar material, with its unusual texture and color, immediately caught the attention of researchers. The discovery was announced on the Chinese-language website Our Space, and quickly made headlines worldwide. Speculations about the nature of the substance ran wild, with some suggesting it could be evidence of volcanic activity, while others theorized it might be glass created by the intense heat and pressure of a meteorite impact. Given the Moon's lack of atmosphere, which prevents erosion and weathering, any anomaly on its surface carries significant scientific interest. Mission scientists redirected the rover's planned route to investigate the mysterious material further. Using the rover's panoramic camera and visible near-infrared spectrometer, they collected detailed data on the substance. The findings pointed to the likelihood that the material was impact melt breccia, a mixture of minerals and lunar soil fused together by the heat and force of a meteorite collision. Its glossy appearance and unique composition suggested it had been formed under extreme conditions. This was not the first time a peculiar material had been found on the Moon. During the Apollo 17 mission in 1972, astronauts Harrison Schmitt and Eugene Cernan discovered orange soil near Shorty Crater. The soil, composed of tiny volcanic glass beads, was later determined to have been formed by fire fountain eruptions billions of years ago. These eruptions sprayed molten lava into the lunar sky, creating droplets that solidified upon cooling. The Chang'e 4 discovery bore similarities to this earlier find, reinforcing the idea that the moon's surface holds a diverse array of materials formed through various geological processes. The implications of the Chang'e 4 discovery extend beyond understanding the moon's geological history. It also provides insights into the role of meteorite impacts in shaping celestial bodies and the processes that occur in the absence of atmospheric interference. Additionally, the mission underscores the importance of exploring uncharted territories. The far side of the moon, with its unique environment and lack of human intervention, offers a pristine laboratory for studying the solar system's early history. The success of Chang'e 4 also highlights China's growing prowess in space exploration. By achieving the first-ever landing on the moon's far side, China demonstrated its ability to overcome significant technical challenges, such as establishing communication in a region shielded from direct radio signals. This achievement not only cements China's position as a leader in lunar exploration, but also sets the stage for future missions, including sample return missions and the development of a robotic research station near the lunar South Pole. As scientists continue to analyze the data collected by Chang'e 4, they are piecing together a more comprehensive picture of the moon's history. The mission's findings contribute to our understanding of lunar geology, impact processes, and the interplay between the moon and Earth over billions of years. Moreover, the discovery of the gel-like substance serves as a reminder of the surprises that await in the unexplored corners of our solar system. The moon, often considered a stepping stone for deeper space exploration, remains a focal point for scientific inquiry. With plans for manned lunar missions, lunar bases, and resource extraction on the horizon, the lessons learned from Chang'e 4 will undoubtedly inform future endeavors. The mission's success demonstrates the value of perseverance, innovation, and curiosity in uncovering the secrets of our celestial neighbor. The gel-like substance found by Chang'e 4, while initially puzzling, ultimately revealed itself to be a product of the moon's dynamic and ancient history. It stands as a testament to the mysteries that await discovery on the lunar surface. As humanity looks to the stars, missions like Chang'e 4 remind us that even the closest celestial bodies hold untold stories waiting to be uncovered. Each discovery not only deepens our understanding of the universe, but also inspires the next generation of explorers to reach for the unknown.